Here, so I better get started. Must be a traffic jam on the internet today. Actually, about 20 minutes ago, I lost internet service for about 3 minutes. I don't know what's happening to my internet provider. For many years, they're like, you could trust your life with how steady they are. Now you don't know. Well, anyways, good morning, everybody. Welcome to another wonderful morning of chemistry with your host, me. Let me do that again. Hold on. Forgot to pin my video. Let's start again. Good morning, everybody. Welcome to another exciting morning of chemistry with your host, Dr. White. And welcome to Chem 1211. All right. Today, as I promised, what we'll be doing today is one, we'll be going over problem set 10, chapter 10, parts 1 and 2. Then we'll go to the next chapter, because I think on Tuesday, I covered everything you wanted to know, how to go from moles to grams, grams to moles, and moles to molecules, and molecules to moles. As I think of it, I did a real tour de force. But anyways, after that, we'll be teaching you some exciting stuff today, and then we'll get to the lab. And I created it a couple of days ago. I knew what I wanted to do, but I finally wrote it, and it turned out good. I think you'll love it. So let's get started. All right, on the board, on your screen, you should see chapter 10 problems, part 1, and these are the answers. Everybody see that? Good. Thank you, thumbs up, people. All right, now the question is, what ions will the following elements form? Well, first one, sodium. How do you do that? Well, you look at how many electrons and protons. Oops, I better bring up something important. Hang in there. All right, let's get back because I needed. And now you should see the periodic table. Everybody see the periodic table? Thank you. And if we look at the periodic table, the question was, what ion does sodium form? The first thing you have to know is how many electrons and protons sodium has. And that's the atomic number. And the answer is 11. Now that we have that, the next question is, what's the nearest noble gas? Remember, noble gases are in this column. And
I can't see the table, Dr. White.
No, I should have asked. Hang in there. It tells me you can. Now can you see it? Okay. All right,
Yeah.
Let's do that again. Instant replay. I just wound back to tape. If you've ever taken a tape and going backwards, that's what it sounds like. But anyways, we're trying to find what ion sodium forms. You look at the periodic table because you need to know how many electrons and protons sodium has. And the answer is the atomic number tells you that. And the atomic number for sodium is 11. So sodium has 11 protons, 11 electrons. Next, you have to find what's the nearest noble gas numerically. And if we look across here, we have two choices, actually three, but one is too far away. One is at 10, neon, the other argon at 18, which is closer numerically. And if you look at 11, it's closer to 10 than 18. Therefore, sodium wants to have the same number of electrons, which is an octet, the valence electrons, and therefore it wants to have 10 electrons. With that information, we say sodium get a red pen. Sodium has 11 electrons, 11 protons. It wants to have 10 electrons. It doesn't change the number of protons. There's still 11. Each proton is a +1. Each electron is a -1. Do the math. Remember, these are exact numbers. I get -10 plus 11 added up. I get a +1. And the answer is what ion, or show the ion. And you do that by the chemical symbol. And then for plus, you do that. Now, if we're a larger plus, we do something else. And let's see if I can find it. Let's do calcium. Now, how many electrons does calcium have? 20. How many protons? 20. How do you know? The atomic number. What's the nearest noble gas numerically by atomic number? You have two choices. All the way down here, krypton is at 36. That's 16 away. Argon is 18, 2 away, which is a smaller number. We do tough math in my class, and hopefully you always pick 2. Therefore, it wants to have the same number of electrons as argon. And therefore, I didn't do this here, so we'll do it up here. Calcium has 18 protons, doesn't matter which one you put on. No, I got that wrong. Has 20 protons. Uh-oh, my memory's going. Oh no, I better eat more fish. You know, that's brain food, so they say. All right, calcium, 20 protons, 20 electrons. It wants to go to the same number of electrons as the nearest noble gas, argon, 18 electrons. You don't lose the protons. Each proton is a +1. Each electron is a -1. Do the math, +20 minus 18, add those up, you get a +2. How do you show that? The atomic symbol, superscript +2, which is the old way, or you can write, which I don't like because I like the old way better, 2+. Don't ask me why, but I do, mainly because I grew up with it. And that's how you do it. Oh, let's do one more. These are fun. By the way, 3 points each. Let's do nitrogen. Now, what ion does nitrogen form? Here's the periodic table. I'm going to share some of the fun. Why don't you find how many electrons nitrogen, protons nitrogen has, and what's the nearest noble gas numerically, and how many electrons that has? I'm going to let you do the whole problem. I see everybody working on it, and then I'll do it. Again, what ion does nitrogen form? Dr. White loves nitrogen, but carbon better. Oxygen, Dr. White loves, and hydrogen too. Sodium and potassium are important, so is calcium, because I don't want osteoporosis. And when you're done, give me a thumbs up or smile or do both. Or do none of the above. It's a free country still, I hope. No more politics. Let's talk about happy things, ions. All right, anybody need more time? Going once, twice, done. All right, let's take a look at this. What ion does nitrogen form? First of all, you need to know how many electrons and protons nitrogen has. You look at the atomic number up here in the corner, 7. By the way, this is the periodic table you'll be given for test 2. And it has 7 electrons, 7 protons. Atomic number tells you how many protons, how many electrons. Now, what's the nearest noble gas numerically by atomic number? Well, you've got a couple of choices. You go helium, that's 5 away. Neon at 10 is 3 away. And argon is 11 away, based on the difference of atomic numbers. What's the smallest difference? And 3 away at neon. So nitrogen wants to have the same number of electrons as neon, so I'll have a stable octet and be happy. Elements like to be happy, just like people. So, look out, it's bad humor time. If we come over here, nitrogen has 7 protons, 7 electrons. It wants to go to the same number of electrons, 10, as its nearest noble gas. It will not change protons. Now, each proton is a +1. Each electron is a -1. Multiply. Add this up. Dr. White learned this in 2nd grade, so I can do this pretty good. Been doing it enough years. That's adding and subtracting. And this would be a -3. Now the question is, draw the ion or show the ion or what ion. Therefore, you put the chemical symbol, then superscript to the right, either hold on, cable is in the way. Wondering what's blocking me from my tablet. You can write it this way or this way. Either way works for me. Now, look out, Dr. White's going to another color.
In this case, do we have to show the work or just only the
Oh, you're ahead of me, Diana. You can read my mind. Oh, that's dangerous. I'm going to protect my brain. No, it's real bad humor. Now, everything here, you don't have to show.
Okay.
But I'm showing you, all you would have to do would be this or this for the answer. Now, why do I show you this? Because I'm teaching you how to do it. If I just said, well, here's the answer, well, how did I get there? Now you know. Now for these, I didn't show this, but that's why I'm going through it. But I think by now you should be able to work it out on your own. If not, you can either ask a question now, because there's no such thing as a dumb question in my class or in my life period, or you can come to my office hours. Now, would you like me to do another one? I see a couple people. Anyone have a favorite from what's left? C, D, or you can pick one from the periodic table from the alkali metals, alkaline earth metals.
Let's do F.
F. Oh, my favorite, carbon. The question is, draw the chemical, the ion. What ion will carbon form? So we need to go to our periodic table. And hopefully, does everybody see the periodic table now? You try it first, then I'll do it. I have time this afternoon. I'm going to try, I saw it this morning. I'm going to try and call the customer service number for Zoom. I sent them an email twice and nobody ever got back to me. This one's a little challenging because carbon is one of those that really doesn't form alone as an element ions, but all right, anybody need more time? Now I see everybody working. I'm there on my monitor. When you're done, give me a thumbs up. Thirty-second warning. I'll even time it looking at one of my watches. I brought back to life. I fixed myself an old watch I had. I'm waiting for the watch band, which died long ago, to come back. I ordered one for that. All right, let's do this. Now, carbon is at 6. And first of all, you have to find out how many protons and electrons does carbon have. And at 6, the atomic number tells you 6 electrons, 6 protons. Now, where's the nearest noble gas? Now here, neon is 4 away, so is helium. Let's go to neon. If you did either one, I would do this, which means I probably wouldn't put this on a test because I wouldn't give you a headache where there might be 2 options. But let's do this, and I'll tell you in real life, carbon element alone doesn't form ions. Usually these two and these always do. But just for academic, so the closest is 10. If you pick 2, I'll do that too, so you won't feel left out. I don't want students feeling left out. It's not nice. All right, so it's at 6, wants to go to 10. I'm gonna have to go to my whiteboard. I'm running out of room on this sheet. All right. Carbon has 6 protons, 6 electrons. It wants to go to the nearest noble gas with 10. electrons, the number of protons will stay the same. Each proton is a +1. Each electron is a -1. Do the math or multiplication. Well, that is math. Add these up and you get -4. How do you show that? Now, it could go the other way, and this is why I would never put this on a test. And also in real life, carbon alone doesn't form ions. It forms ions and molecules, but that's something I'm not teaching in this class. But if it did go to the nearest noble gas, which would be 2, let's see, I don't want to confuse you. Still has the same number of protons, but now it would have 2 electrons. And now if we do the math, it would be each proton is a +1. Each electron is a -1. And therefore, if it went this way, it would be this or my hand didn't want to do the other way because I don't like to do it. I have to force it. Now, which does it go to in real life? In terms of this is more an artificial problem because in real life, carbon element never forms an ion. It's just too far away from noble gases. It's involved in covalent bonds, not ionic. But that's how you do it. All right, let's move on. If you have questions, see me after class. I'll always stay around late. All right, let's move on. The next thing is, what's the empirical formula, or sometimes I'll say the simplest formula of molecules with the form from the following ions. Now, oh, Dr. White wrote a note to all of you. To do this problem correctly, remember, all molecules have a net, and this is the most important thing about this, 0 charge. Therefore, the ions in the molecule have to add up to 0. Let's look at the first one, A. This is a +1. This is a -1. Does it add up to 0? Yes. So the formula would have 1 sodium, 1 bromine, and you write it this way. Now let's look at B. B is a +1 sodium plus a -2 oxygen, and that has to add up to 0. Oh, it doesn't. You can't change the charge, but you can change how many. Well, if I look here, how many do I have? I need a -2. What do I multiply 1 by to get +2? Times up 2. So this tells me I need 2 sodium. What's the number in front of the bracket? When there's no number, it's 1. 1 oxygen. And this shows you 2 sodium, 1 oxygen. When there's a 1 here, you don't put the number. And that's that. Now, for polyatomic ions, notice D, we have a +2 magnesium and now a -1 hydroxide, OH, and this has to add up to 0. Oh, it doesn't. Well, I can't change the charge, but I can change how many. This needs to be a -2. I'll put a 2 there. So that means I need 1 magnesium and 2 hydroxide. For polyatomic ions, we put them in a bracket. And I have 1 magnesium, and how do I show 2 of these? Bracket, close bracket, subscript to the right, 2. And that's how you do it. Your turn. I'm going to share today because I'm in a sharing mood. I always am. What would be the empirical or simplest formula of a molecule containing calcium +2, nitrate -1? NO3 is nitrate. And for all of you who are able to make it this morning, thank you. And for those of you who weren't able to make it, well, this is a asymmetric course, so don't forget to watch the videos. And when you do, don't forget to give me a thumbs up on YouTube. That'd make my day. I think I'm going to start doing product placement in my lectures, like buy this product so I can get money when I put it on YouTube. Not. All right, I think everybody's done. I should be done with my bad humor. Now, remember, all molecules have a net zero charge. Therefore, this is a +2. This is a -1. It has to add up to 0. It doesn't. I can't change the charge, but I can change how many. If this is a +2, I want this to be a -2. What do? -1 times 2 is -2. So what does this tell me? There's 1 calcium. There's 2 nitrate. How do I show a polyatomic ion? More than one of them? Now we have NO3, close bracket. How many do I need? 2. So I'll do that, and that's how you do it. Oh, these are fun. Let's do another one. What would be the simplest molecular formula or empirical formula between a lithium +1 and a sulfate SO4 -2? Have you noticed I've already gone over this before, but in the problem set, I get to do it again and let you think about it. So it burns the pathways in your brain how to do the right answer. I don't know if that makes sense. I'm a chemist, not a brain scientist. What do they call those? Psychologists and psychiatrists? I'm just a crazy chemist. Don't forget, it's TGIT. Thank God it's Thursday. Look out, I'm on a winning streak. And just think, you have to pay for all this bad humor. All right, when you're done, give me a thumbs up. I see some people done. Thank you, Andrew. All right, let's do it. Now, what should you remember? All molecules have a net zero charge. Therefore, lithium cation has a +1 charge. sulfate polyatomic ion has a -2 charge. This has to add up to 0. It doesn't. You can't change the charge. Why am I repeating that? Because students always try to do that, and it's always wrong. So please don't. But you can change how many. If this is a -2, this has to be a +2. I do that. So I need 2 lithium and 1 sulfate. How do I show that? 2 lithium and 1 sulfate. When there are only one of these polyatomic ions, you do not use brackets. All right, let's get back to the problem set. If you notice, I have other examples and you can work it out on your own. All right, next one, draw the Lewis structure. Ooh, and circle all double and triple bonds for the following. Before we do this, let's slip down. Oh, it's not on this one. Let me remind you, it's on the part 2, but I'll do it right here. All right, there are 3 types of covalent bonds, and they are single bond, double bond, and triple bond. And you should know a single bond is 1 pair of electrons, double bond, 2 pair of electrons, triple bond, 3 pair. Let's say it again. And everybody, along with Dr. White. First one, single bond, 1 pair of electrons. Next, double bond, 2 pairs of electrons. Finally, triple bond, 3 pairs. Now, when you're doing Lewis structures, you need to do valence electrons. So if we look at A, how do you draw the Lewis structure for bromine? Br2, bromine gas, which exists in Dr. White's work with this stuff, and also chlorine gas, quite hazardous stuff, but you do what you have to do, and you work with it and be careful. And I have been. So, first thing we have to do is go to our periodic table. And I'll ask all my thumbs up people, see the periodic table? Thank you. All right, now, if you look at the top of each column, the Roman numerals, or as I put in the numeric numbers, tell you how many valence electrons. And if we go over to the halogens, bromine has 7 valence electrons. Again, the number on top tells you how many valence electrons. Now, for bromine, we have 7 valence electrons. This you don't have to do. And you put 1 dot on each side before you double it up. And if I had 2 of them, and notice this bromine has 1 unpaired electron, and this one has 1. And they say to each other, oh, I've got an electron, you've got an electron, let's share, and they do. And this is how you draw it. Don't forget to put in the non-bonding electrons. Electron pairs that are not involved in a chemical bond are called non-bonding electrons. Now, if we look at nitrogen, the question is, draw the Lewis structure for that. Now, nitrogen, if you looked at the periodic table, has 5 valence electrons. If I had 2 nitrogens, how do you know that? From this, each one has 3 unpaired electrons. And one says to the other, but you know atoms could talk. They can't. No, not really. I've got 3 unpaired electrons. You've got 3 unpaired electrons. Let's share. And they do. 3 and 3 make 6 electrons, or 3 pairs. Notice the non-bonding electrons on top are still there. And it said circle all double and triple bonds. Oh, look, 3 pairs of electrons, triple bond. Now, let's go down to this one. Whenever you see an alkali metal or alkaline earth metal, especially the alkali metals like potassium, sodium, or lithium, they always form a +1 cation. They give up an electron like that. They are never, ever in covalent bonds. At least I've never found an exception to that. And I've been asking other chemists for years now. Do they know? Oh, good question from Diana. Do you have to show your work? No. I do this always in class because that way you can see the mindset. Melissa, can you see the table now? Which table? The periodic or the, I don't have.
It was from earlier. I'm all good.
I'm glad to hear that.
Thank you.
We got an all good student, hopefully all good today. I'll let you figure out if I'm good today. But anyways, my sense of humor switch is on full. But anyways, all alkali metals form a cation. So if you're asked to draw the Lewis structure of potassium cyanide, KCN, what do you do? Well, you go to a place where I have more room to write. Again, you're asked to draw the Lewis structure. And we honor Dr. Lewis by using his name because he's the one who invented this. So, first of all, this is going to form a +1. It lost an electron to get that. And we just showed you how to do that, like sodium. Now, let's look at carbon. And carbon has 4 valence electrons, and nitrogen has 5 valence. I do this all the time in my work, so I know this, but let's see if Dr. White's lying to you. I better check. Everybody see the periodic table? Give me a thumbs up. Excellent, thank you. All right, now we have carbon and nitrogen. We're doing Lewis structures of molecule. We need valence electrons. You look at the top and you see 4 valence electrons for carbon, and nitrogen's right here. Look at the top, 5. By the way, V is Roman numeral for 5. IV is Roman numeral for 4. Oh, good news. I wasn't lying to you. I got it right. Now, this part, I'm going to do the Lewis structure for each one. Now, notice carbon has 4 non-bond or single electrons. Nitrogen has 3. So carbon says to nitrogen, you've got 3, I've got 3, let's bond them together to form, what kind of bond is that? A triple bond. Now, the non-bonding electrons on nitrogen are still there. The 1 extra electron is still there because you only use 3 of the 4 over here. But where did this electron go? Well, it went to the carbon. Now, carbon and nitrogen, called the cyanide anion, has an extra electron, so it has a positive charge. And potassium cyanide, you have an ionic bond between the potassium and the cyanide. And I'm going to give you 2.8 seconds. What kind of bond is between carbon and nitrogen. I gave you some bonus time. 3 pair of electrons, that is a triple bond. And if I were asking you to circle the triple bond and double bonds, you'd circle that. And that's how you do those. Oh, let's do one more.
Only we have to say triple, single, or double bonds, but we don't need to show the work, right?
Right.
Okay.
All you would have to do for this answer, if I asked you, draw the Lewis structure of potassium cyanide, this is all you would have to write down. Okay? This is all in the box here. That would be your answer.
Just one
This
second.
stuff up here, you don't have to show, but I'm showing you how do you get to the answer, and that's why I always show it. And why don't you try this one? Now, I'm going to help you out. Potassium has 1 valence electron, but it's potassium, and you knew what that does. Oxygen has 6 valence electrons, and hydrogen 1 valence electron. And why don't you try and draw the Lewis structure for potassium hydroxide? Boy, let's look at the clock. Time flies when you're having fun with chemistry. Well, while you're doing that, I'll do a product placement. Don't forget to buy a Texas Instruments calculator. Now I got to see if I can send them a bill. Remember, alkali metals always form a positive charged cation. When you're done, give me a thumbs up. Or if you give up, give me a thumbs up. Hopefully you're not giving up. Uh-oh, the clock's ticking. Not really. I have all digital electric clocks in my office. I don't think I own a wind-up clock anymore. Wait, I haven't used one in a long time. I have 2 wristwatches that do wind up that aren't electric. Given to me long ago as gifts. Beautiful ones. I'm just not a watch person. All right, 20-second warning. I even got the watch out to do it accurately. All right, let's do this. Watch. If you're having problem, go back and try this and do it on your own. If we look here, oh, an alkali metal. That's always going to form a plus cation. Oxygen, 6 valence electrons. Put one on each side and then double up. Organic chemists like to double up on the top and bottom. Doesn't matter. Hydrogen, oh, this is a simple one. 1. Now, hydrogen looks at oxygen and says, oh, you've got one unpaired electron. Let's share. And they do. Remember, all atoms want to have an octet. If they're not ionic, even then they have an octet, but for now. And the one exception is hydrogen's octet is 2. So it's got its octet 2. But oxygen has 1, 2, 3, 4, 5, 6, 7. Oh, that's not 8. But where did the electron go from the potassium? It went here. It gives it up. And now this has an extra electron from what it started with. So I'll have a minus charge, and that's how you do it. And with that, I think it's time to take a break. So I'll see you in 5 minutes. Please come back. Or I guess as Arnold says in his movies, I'll be back. I'm not ever going to be an impersonator. It was one of the worst impersonations of Schwarzenegger ever done. See you in 5. All right, let me get you all back. Have used this all day, so it's time for, it's time to get back to work. So let's get back to work. Now, everybody, pay attention. Problem 4, just put an X through. I didn't teach it. Whenever I put this on a test, most students get these wrong. So last semester, the summer, I decided to not teach this. And there's other things I can spend more time on that it's more important to you. So just put an X through this here. Not on the test. So just ignore it. The way you do it is valence electrons with, but anyways, I'm going to move on to part 2, which is sort of a repeat of part 1, some of it, and some of it's not. Now, let's look at part 2. Does everybody see part 2 on the screen? Thumbs up, people. Can you see part 2? Thank you. I think I've got the fastest thumbs up group this side of the Mississippi and the other side too. All right, you should know what is a covalent bond. It's sharing pairs of electrons between two atoms. You should also know what's an ionic bond. It's not down there, but you should know that's the transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. Now, we just did the Lewis structures, so you can go back and review this again. Now, what are the 3 types of covalent bond? Ooh, deja vu all over again. That's something Yogi Berra, who was a famous baseball player and manager, was known for great sayings he came up with. But anyways, single bond, 1 pair of electron, double bond, 2 pair, triple bond, 3 pair. You should know this.
Excuse me, what problem set are we reviewing? What number?
Set chapter 10, part 2.
Oh, part 2. Part 2.
Part
Thank
2.
you.
You're welcome. Remember, all questions are good questions. So now you're on track with us. I bet that's a good feeling. Oh no, the pen changed color on me. You should know the 3 types of covalent bonds. Single bond. You should know how many pairs of electrons each bond. Single bond, 1 pair. Double bond, 2 pair. Triple bond, 3 pair. So that's that. Now, give an example of a molecule that hydrogen bonds. That's any molecule that has either nitrogen, oxygen, or fluorine with a hydrogen atom on it. And if you notice, water is an example. That's probably the most important. Ammonia, hydrogen fluorides, all your alcohols. Next time you're in a tavern or a place where they're selling mixed drinks, you can tell the bartender, oh, look, you can make a mixed drink with alcohol and water because of hydrogen bonding. Don't. Bartenders do not want to learn about chemistry. I know firsthand. They just give you, and also don't tell them I'll teach you something else later. You shouldn't tell them. But meanwhile, you should know at least one of these. Give an example of a molecule that can hydrogen bond. Now, remember, hydrogen bonding is a very weak force between Let's do a water. Here we have 2 water molecules. You know, in 18 grams of water, which is 1 mole, the molecular weight of water, there's 6.02 times 10 to the 23rd molecules of water. So we're just looking at 2, but it's good for all of them. This, because electronegativities, the oxygen is slightly negative, the hydrogens are slightly positive. Same thing over here. I'll never ask on a test, but it's a good thing to know. And there's a weak electrical attraction right here, and that's the hydrogen bond. It's not a true chemical bond, but it's a very weak force, but it's strong enough to do some amazing things. What's amazing? I better show you. See the water in my water bottle? Ice Mountain. Oh, can I get money from Ice Mountain now? But anyways, notice it's a liquid. That's because of hydrogen bonding. Also, next time you turn on your faucet and you see the water going down in a stream, that's because the water molecules are hydrogen bonding, which is why I always smile inside when someone says, I hate chemistry. No, you don't hate chemistry. You just hate whoever taught it to you because they probably didn't do a good job, which happened to my sister in high school. I was, by the way, personal time, I have a sister who's 7 years older, another one's 7 years younger. Dr. White's in the middle. So when she was in high school, I was about 7 or 8. I was just starting to learn chemistry then for my father, so I couldn't tutor her. But to this day, don't talk chemistry. I hate it. So I don't. All right. We have just finished the practice problems for chapter 10. Remember, if you have any problems doing those, always feel free to see me after class or come to my office hours on Monday, Wednesday night on Zoom from 6 to 7:15. I need to stay a little later because you need extra help. I do. I don't have a trainer plane to catch at least next week or the week after. And so don't forget, it's time to move on. And it's time for a new chapter time. And this new chapter, some of it I forgot to cut out the slides, you'll see, is chapter 8. If I can get to the top of it. And parts of chapter 7, chemical calculations, formula mass, which we've already done, moles, but most importantly, chemical equations. And we talked about the molecular weight, so I'm going to skip through this. We've done this already. We've done molecular weight of things like this. You should be able to do that. Talked about the mole, which is Avogadro's number. 1 mole equals 6.02 times 10 to the 23rd. But in chemistry, we talk about atoms and molecules. The reason this is in yellow because Dr. White forgot to cut this out. So I'll go through it again. And remember, 1 mole of atoms or an element, this actually should be, or same thing, but I should also have equals Avogadro's number of atoms. 1 mole of a compound equals these many molecules. And don't forget, there's only a couple more shopping months till my birthday, and all Dr. White wants is a mole of pennies. Is this pennies? That'd be 100 million times a billion, so 100 million billion dollars. If you don't want to do it in pennies, I'll take a check, as long as it's certified. Oh my, on a winning streak today. All right. So you know about these two ratios. And I showed you your good buddy, your good friend, unit analysis, which we used here. Oh, don't forget significant figures always. Talked about the molar mass, which, note, your instructor will use molecular weight instead of formula weight. And what this really means is 1 mole of an element equals its atomic weight in grams. 1 mole of a compound equals its molecular weight in grams. The molecular weight is the sum of all atomic weights. So if I were to ask you to go to the lab and get me 1 mole of water, we'd weigh out 18 or 18.0 grams, and that's how you do it. And we went through this on Tuesday in force, and last Thursday we started. And just like you can skip, same thing, we did stuff like this. Calculated the mass of the molar quantity. Acetic acid has this formula. How many grams is 0.3 moles? We've done this. Same thing here. You can go back and try this. All right. Wake up. New stuff. New stuff. Ooh, my storm whistle. Wow, that hurt. These are the world's loudest whistles. Yes, I'm a whistle collector, have been since I was in high school. In fact, I lost one. I was thinking about getting, I can't find whatever happened to my police whistle. But anyways, let's move on. New stuff. Chemical equation. If I could turn the switch up to 100, I just did, even though it only goes up to 10. That's how important. Now, what is a chemical equation? I'll never ask this on a test, but you should know a chemical equation is a written statement that uses symbols and formulas instead of words to describe changes that occur in what we call a chemical reaction. Mix two things together, make something new. How do you describe that in chemistry? Chemical equation. Now, there's conventions that are followed in writing chemical equations. I will never ask you on a test or a final, what are the conventions used, but I will always follow them, and you should too. First of all, I use the correct formulas of the reactants and starting materials. Use the correct formula of products substances produce. Uh-oh, I better teach you something very important. Everybody see the plain white sheet on the screen? Thank you. All right, let's do a very simple chemical equation. What this means is A plus B makes C. Whatever at the base of the arrow, in this case on the left, are called the reactants. And you should know this. Also, because I've spent most of my adult life working in the chemical industry, in academics, they call it the reactants. In the chemical industry, we call them the starting materials. And more likely than not, in a class, I'll use starting materials and reactants. Now, what you make is at the head of the arrow, and that's C, and both groups call that the product or products. There's more than one, which it can be, it's called products, or if there's only one, it's a product. So A, and the plus symbol means and, you react A and B together and you make C. And this is a chemical equation. Now, the formulas for A, B, and C have to be correct. Therefore, if I react oxygen, hydrogen plus oxygen and make water, That's wrong, because water is not H5O. Water, as I think you all should know, is H2O. If you take hydrogen gas and oxygen gas and a little spark, don't try it at home, it's dangerous, but I've done it. You make water, which is quite an expensive way to make water. So remember, in a chemical reaction, on the left side of the arrow, those are the reactants or starting materials. On the right side of the arrow, those are the product or products. So in this reaction, hydrogen plus oxygen make water. I'm going to ask you to try first. What are the products? What are the reactants? Time's up. On the left, these are the reactants. So on the left, hopefully you all know your right from left. Time out. This is your right, this is your left. I'll do it in slow motion. This is your right, this is your left. In organic chemistry, I teach you the difference between your hands, and there is. But anyways, this is not organic chemistry. Now, the other question is, what's the product? And the product is always on the right, and the product of this reaction is water. So, reactants, always on the left of a chemical equation, products on the right, or product. And use proper chemical formulas. It has to be true to the data. The reactants and products are separated by arrow, and the arrow is always pointing to the products. Plus signs are used to separate different reactants or different products, which I just showed you. Now, there's a validity check. For a chemical equation, I'll never ask you that on a test, but must be considered consistent with the experimental facts. When I put hydrogen and oxygen together with a spark, you do make water. You don't make alcohol. You make water. And here's very important, because of conservation of matter, there must be the same number of atoms of each kind on both sides of the equation. Conservation of mass or matter, I think they're the same. And this means you always have a balanced chemical equation. And a balanced chemical equation, I'll never ask you this on a test, has the same number of atoms of each element involved in the reaction on each side of the reaction. Now, one of the skills you need to know, better get your attention. Everybody wake up? All right. Well, am I being cruel today? But anyways, what I'm going to teach you, balancing chemical equations is one of the most important skills in chemistry. And therefore, on test 2 and the final, I usually have 4 problems, 3 points each, 12 points. So this is a skill you should have. Next week's lab will be for you to practice balancing chemical equations before test 2. So pay attention. When you have an unbalanced chemical equation, it's brought into balance by adding the coefficients. Coefficients are numbers in front of the formula to adjust the equation to adjust the number of reactants and product molecules So you have the same number of atoms on both sides and the same number, same type of number. Now, here's a little note to Dr. White. And remember the torsion balance or teeter-totter analogy? How many of you have ever seen a teeter-totter? And you know, when you have two kids weighing the same, it's like this. You have one heavier one that goes like that, one's like that, it's balanced. How many of you ever seen the old torsion balances with the chains coming down to a pan? You put something on this side and something on this side, and it goes, oh wait, we've got the internet. This is, here we go. Everybody see this or this one right here. And those are examples where you put it on each side. My father actually had something like this in his drugstore. I have it's nicer than this and I have it. One of my important memories from him. But when both sides have the same weight, the levels of the pan are equal. Will you do the same thing when you balance chemical equations? Now, let's look at this equation that I have on the screen. Everybody see H2 plus O2 give water? Everybody see that? Thank you. Now, is this balanced? And the answer is no. How do you know it's not balanced? And let me rewrite it to get some more room down here. How many hydrogen atoms are on this side? 2 hydrogen. How many on this side? 2. Oh, that looks good. How many oxygen here? 2 oxygen. I'll put a little dash there so you know I'm not writing the number 20. How many here? Uh-oh, 1 oxygen. This is not balanced. So how do we get this balance? Well, if I look here, I have 2 oxygen. How do I get this side to 2 oxygen? You can't change this formula. Can't put a 2 there. Students like to do that, and it's wrong. Water is always H2O. But I can change the number in front. This is called the coefficient. Hopefully I spelled it right. Sometimes I spell it wrong. Anyways, so that's it's looking 2. Sorry about that. So now I have 2 oxygens. Ooh, these are balanced. But now 2 times 2, I have 4 hydrogen. How do I get to this side 4 hydrogen? Because I only have 2. Well, I can't change this, but I can change the coefficient to number in front. Well, if I want to get 4, I have 2. How do I know what number? 2 goes into 4. Get your calculator out 2 times. And now how many hydrogens on this side? I have 4 hydrogens. Now you count, even if they're in different molecules, you count all the hydrogens. So the balanced chemical equation for this reaction is this. 2 hydrogen atoms, and when there's no number there in front is, you assume it's the number 1. 1 oxygen atom make 2 water molecules. And now you have a balanced chemical equation. Now, here's an important rule for balancing chemical equations. I could have multiplied this by some number, say 4. So I have 8 hydrogen plus 4 oxygen make 8 water. And if you check it, this would be 16 hydrogen. This would be 8 oxygen, 16 hydrogen, 8 oxygen. Well, this is wrong. And why is it wrong? Because the rules for balancing a chemical equation is you always want the smallest ratio of the coefficients. If you can divide all the coefficients by the same number and get whole numbers, because these are exact numbers, you can't have half a molecule existing, no way, then you should. So if I divide all these by 4, I would get this, which is the correct way. And if you write this on a test like this, I'm going to give you 0 points. So make sure you remember, if you can divide all the coefficients by the same number and get a whole number each time, not a fraction, then you better do that, and that's the numbers you use. Now, if we look at this next balance, it's not balance, the next equation, we have sodium reacting with chlorine gas to make sodium chloride, table salt. Remember, please pass the NaCl. And the question is the balance. Immediately you see 2 chlorine, 1 chlorine. It's not balanced. I'm going to let you try first to balance it. Remember, you can't change the formula, but you can change the number in front, and that's called the coefficient. Have fun. While you're doing that, I'm going to have some water that's hydrogen bonded. Don't forget, when you see my videos, do a thumbs up on YouTube if you'd like. I'm just kidding, you don't have to. All right, 10-second warning. Time's up, put down your test. Just practicing. All right, let's take a look at this. If we look at this, is it balanced? The answer is no. And now what do? Well, you look here and you say, I have 2 chlorine, and over here I have 1 chlorine. I need 2 chlorine. How do I get, I have 2 chlorine here. How do I get this to 2 chlorine? I can't change how many, but I can change the coefficient. So now I have my 2 chlorine. And these are balanced for chlorine. But now I look on this side, I have 2 sodium. Oh no, I only have 1 sodium here. How do I get 2? No, you don't put a 2 there because that doesn't exist, and Dr. White will mark it wrong. But I can change the coefficient. How many? And now I have 2 sodium, and I'll double check. Is it balanced? You should have the same number of atoms on both sides. 2 sodium, 2 sodium, 2 chlorine, 2 chlorine. It's balanced, and that's how you do it. All right, what I'm going to do now, pay attention. I'm going to teach you a few little I call them tricks, but they're just methods to help balance equations that help Dr. White and help you do them correctly and easily, which is always a good thing, or I should say less stressful. Oh, by the way, I don't know if somebody's going to ask this, but you know, you'll always see me showing underneath here my work. Do you have to show that? No, you just have to write the balanced chemical equation. But this always helps me on the right track. Let's do one that Dr. White will do, and then I'll have you do one. And let's do something from the real world. And this is propane. You know, you use that for your barbecue. When it reacts with oxygen, this is called combustion. It makes CO2, carbon dioxide, water, and also, you don't show it here, energy, which is the heat, the flame. Question is this balanced? Well, immediately I can see 3 carbons here, 1 carbon there. So how do you balance it? First, number one trick or way of making your life easier when you're balancing chemical equations. And it works. You don't have to do it, but it makes your life easier. Do oxygen and hydrogen last. When you're balancing a chemical equation, do hydrogen and oxygen last. You don't have to, but when you do it, it makes your life a lot easier. And by the way, Dr. White likes to keep his life happy and easier any way I can. So let's look at this. So we've got carbon, hydrogen, oxygen. So Dr. White's going to follow Dr. White's advice. I have 3 carbons on this side. I only have 1. How do I get it to 3? I can't change how many carbons in carbon dioxide, but I can change the coefficient. So now I have 3 carbons. That's done. Well, all we have left are hydrogen and oxygen. I'm going to do hydrogen because I'm going this way. You could do oxygen. Notice I have 8 hydrogen. Oh, this side I only have 2. How do I make it 8? You can't change that number, but you can change the coefficient. 2 goes into 8 4 times. Aren't you glad, Dr. White? And that's a 4. And now I have 4 hydrogen. So I've done my carbon, done my hydrogen. All that's left now is oxygen. Here I have 2 oxygen. Ooh, how many on this side? Let's look. You do the total. 3 times 2 for CO2 is 6 oxygen. 4 times 1 is 4 oxygen. Therefore, we really have 10 oxygen on this side. Oh, how do I get 10 on here? Well, there are 2 in each one of these. 2 into 10 is 5. And 5 times 2 is 10. So now I'm going to do my check, just like when you balance your checkbook, even though I hate that. 3 carbons, 3 carbons. 8 hydrogens. Oh, wait, I forgot to change this. That should be an 8. 4 times 2, 8 hydrogen. 10 oxygen, 10 oxygen. So 1 propane reacts with 5 oxygen to make 3 carbon dioxide and 4 water molecules. And we now have a balanced chemical equation. Remember, always do hydrogen, oxygen last. Your turn. And this is called pentane. You don't have to know this, but I'm an organic chemist, so I do. And it's a component in gasoline and other things, and oil, which we use in the chemical industry. And you burn sometimes. And why don't you balance this chemical equation? On a test, if I ask you to balance it, it will always need it to be balanced. When I was a student, teachers would put, I teach an equation that was already balanced, and you have to put down it's already balanced. And that upset me because he asked me to balance an equation. Well, have me balance an equation. Don't play games. And Dr. White doesn't play those games on the test. Remember, leave hydrogen, oxygen last. Remember, you're just starting out, a lot of you, so if you're having difficulties, that happens. I'll be giving you a lot of practice problems to do this. In fact, a whole lab of practice problems next week. Remember, do hydrogen, oxygen last. All right, let's do this because there are other things I want to get to today. All right, let's look at, is this balanced? And immediately you can see 5 carbons, 1 carbon, it's not. And like I said, on a test, if I ask you balance the equation, you're going to have to balance it. Well, I have 5 carbon here. How do I get the 5 carbons here? Well, put a coefficient, 5 carbons. Now, all I have left are oxygen and hydrogen. I'm going this way. Dr. White's lazy. I've got 12 hydrogen here. Uh-oh, I only got 2. How do I get that to 12? Well, 2 goes into 12 6 times. 6 times 2 is 12 hydrogen. Now here I have 2 oxygen. How many on this side? Now here's what you got to remember. You count all the oxygen atoms on this side or both sides. 5 times 2 is 10 oxygen atoms on this side. Plus here I have 6 times 1 is 6 oxygen atoms. Do the math. And I have 16 oxygen atoms on this side. How do I get 16 on this side? Well, 2 goes into 16 how many times? 8. And therefore, I now have 8 times 2, 16 oxygen. Now, before I go on to the next problem, I'm going to check like you balance your checkbook. 5 carbons, 5 carbons, 12 hydrogen. This should be hydrogen, not oxygen. 12 hydrogen. 16 oxygen, 16 oxygen. Success. Oh, let's try one more. This is a little more complex. I'll give you a couple minutes and then I'll do it. So you have ferric hydroxide, sulfuric acid makes ferric sulfate plus water. Remember, leave hydrogen, oxygen last. Try this one. If you're new at this, I'll do it, so don't feel frustrated if it's a little beyond your skill level at this time, but I thought I'd challenge you this morning. Remember, we did this on test 1. Multiply what's inside the bracket times the number to the right subscript to tell you how many atoms in that molecule when you have a bracket. Oh, it's good to see everybody hard at work, balancing chemical equations. Makes Dr. White happy. When you're done, give me the thumbs up. If you're lost, give me the thumbs down. If you're not sure, I guess do horizontal. "25-second warning," and bonus time. All right, let's do it. Now, I'm going to follow my own advice and leave hydrogen and oxygen last. So if I start here, because I'm lazy, oh, iron, there's one here. Uh-oh, there's two over on this side. So how do I get two on this side? Put the coefficient. You can't change how many in the molecule, but you can change how many. So I now have 2 iron and 2 iron. Now see, oxygen, hydrogen, hydrogen, oh, sulfur. I have 1 sulfur on this side. How many sulfur on this side? 1, but don't forget to multiply times 3. So I have 3 sulfur on this side. How do I get this to be 3? I put the coefficient there. And now I have 3 sulfur. That looks like a 5. That's better. 3 sulfur. Now I can do hydrogen and oxygen because that's all they're left. I'm going to do hydrogen first. You could do oxygen, but I'll do hydrogen. And I have how many hydrogens in ferric hydroxide? 2 times 1 times 3. Remember, this times this, there's 3 times 2, so that's 6 hydrogens in ferric hydroxide. How many in sulfuric acid? 3 for this equation at this point, times 2 is 6 also. Do my math, and what do I get? I get 12 hydrogens. Well, this has no hydrogen. Ooh, 2, but I want 12. How do I get 12 hydrogens there? Well, 2 divided into 12 is 6. Or 6 times 2 is 12, either way. And now I have 12 hydrogens. So I got my iron, my sulfur, my hydrogen. The only thing left is oxygen, so I better do oxygen. In the first molecule, how many oxygen atoms? Now I have 1 here, but the 3, here it says 3, but it's times 2. So 1 times 3 times 2 is 6 oxygen. And here, that's a 4. Hopefully you could see it. Times 3, ooh, 12 oxygen. I add them up, that's 18 oxygen. Let's look on this side. I have coefficient is 1, so it'd be 4 times 3 is 12 oxygen, plus 6 times 1 is 6 oxygen. Add it up, move down here because I'm running out of room, 18 oxygen. I think I'm done. Let's check. And over here, I have 2 iron. Over here, 2 iron. 3 sulfur, 3 sulfur. 12 hydrogen, 12 hydrogen. 18 oxygen, 18 oxygen, success. And that's how you balance it. Now, there's a few more things I want to go through, but guess what time it is? It's time for lab. Instead of taking a break, I'm going to go straight through. You'll be done in about 10 minutes or less. So that way you just don't have to sit around for 5 minutes for me to come back. So let's get into lab. First of all, I better open one up. Let me. Yes, the next lab is already up. I did that yesterday. It's in Blackboard. Let me get it already up in here. All right, let me check with my thumbs up, people. Can you see the chem lab, chemical reactions on the screen? Hold on, let me, thank you. All right, today's lab deals with chemical reactions. And a chemical reaction is when two or more substances are mixed together and new substance or substances are formed. And today's lab, you're going to find out how visually can you tell when a chemical reaction occurs. Well, it's simple. Oh, it even says it in the lab. You'll see one of the following 4 signs or changes in the mixture of substances. Those 4 signs are what you visual signs are. 1, you'll see a major color change. That doesn't mean it goes a little lighter blue. It means it goes from blue to red or clear to yellow or major color change. That's 1 sign. Remember, stuff I do in the lab won't be on any test. All right, the next way you can tell you have a chemical change is when you mix 2 or more things together and you see a gas form. How can you tell gases? i.e. means that is, you see bubbles form. So whenever you see bubbles formed when you mix 2 things together, you know you've had a chemical reaction or change. And the next thing is a precipitate form. And what is a precipitate? That's when you mix 2 things together and you see a new solid formation. I don't have any. How many of you have ever seen the paperweight snow globe with the little snowman inside and you shake it up and you see all the snow little particles come by? If our chemists were looking at that and say, oh, look at the precipitate in there. So you don't want to be chemists around when you do snowman. No, never mind. But anyways, the solid floating down or floating in there, organic or regular chemists and organic chemists call a precipitate. So whenever you mix 2 things together, like 2 liquids, and all of a sudden you see a precipitate, guess what? A chemical reaction or chemical change, you can use them interchangeably, has occurred. And then the 4th one is you mix things together and you get a temperature change. And if you have 2 substances at the same temperature and you mix them together and the mixture gets either hot or cold, that's an indication you had a chemical reaction or a chemical change. Now, in today's lab, you will determine if chemical changes occur when you mix 2 substances together. Now, a couple of these I'm going to ask you to do at home. I'm not going to give it away. But before we do this, let's look at the procedure. If you have a solid, put a small amount is used if you have a liquid or a solution, which I'll teach you later on what is a solution. You'll add about 10 to 15 drops, or you could do more. And the procedure you'd use is in a clean test tube. It's always good to start out with clean ones. Put a small amount of the first substance from table 1, then add a small amount of the second substance from table 1. You mix them as illustrated by your instructor. Let's assume this is a test tube, better yet. Let's assume this is a test tube as a pen, but pretend it's a test tube. Never ever mix a test tube like this, because you can get chemicals on yourself. And if you're in a lab, if you have a test tube, hold it like this and go like this 3 or 4 times and it'll be mixed. Now, don't tickle it, because that won't mix it. You really gotta go like that and it'll mix it. The other thing is you can take your stirring rod and put it in, mix it, but a lot of students knock it right through the bottom of the test tube, so I don't teach that. Now, at the other school, we don't have a COD. There are these vibro mixers. You push it down and this vibrates real quick and it makes, they're fun to use. But when you're mixing a test tube, that's the way to do it. See what skills you're learning from Dr. White? Now, what you'll do is inspect the test tube. First of all, you'll feel it. See, is there a temperature change? Does it get hot or cold? Then you look, is there a color change, a precipitate, a solid form, or gas formation, bubbles? If no change occurs, wait a couple minutes and check it again. Then if you're doing the lab in the COD, flush all chemicals down the drain with water, do a final rinse to clean your test tube, and then you repeat steps 1 through 7 for everything. Now, let's look what this really looks like. Everybody see double displacement
In a
reaction?
double displacement reaction of silver nitrate and sodium chloride, we have a solution of silver nitrate, which is colorless. We will add a solution of sodium chloride, which is also colorless.
Watch, this is
When the
cool.
sodium chloride solution is added to the silver nitrate solution, a white precipitate, insoluble silver chloride, is formed.
Oh, let's do another one, you guys. These are cool. These are interesting. Funky music time. Ooh, is that pretty? Ooh, is that pretty? Isn't chemistry fun? Wasn't that fun? And that solid inside the test tube, that's the precipitate. Hold on, no, I'm gonna let you find it. Let's go to the lab. There are others that you'll find. Now, in today's lab, you'll be doing all these in table 1. Now, where it says see note 1, 2, 3, 4, 5, 6, 7, 8 below, those are YouTube for some of them. Now, There are 2 on this chart I'm going to ask you to do at home. You'll do number 5, take some table salt. I assume you all have table salt at home. You should all have water, mix it together. Now you do it in your test tube from your kit or your beaker, whatever, and see if you get a chemical reaction. And how do you know if you got a chemical reaction? If one of these 4 things happen: major color change, gas form, you see lots of bubbles, not 1 or 2, lots of bubbles. You see a solid form once you dissolve whatever you're reacting together, or you see a major temperature change. Now, in today's, you'll do number 5 at home, and you'll do number 8 at home. Sand is silicon dioxide. It's a chemical. One company I worked at, we made glue, a fancy name, we call them resin, that held sand together to make the molds for things like your car engine. And Dr. White knows all about sand. Not all sand is created equally. Now, for the ones that are not 5 and 8, how do you find out? Well, let's look at what happens when you react vinegar and baking powder. Now, if you got this at home, try it in the sink. If not, see note 1 below. You can try it at home, or you can watch this YouTube. Notice here for number 2, a little hint: observe the steel wool surface. And these I have found YouTubes. And for number 8, drain off the water and don't put the sand down your drain. I don't think either you, or if you live at home with your parents, want sand in your drain pipes. All right, now, in this chart, based on either what you do yourself or from the video below, you should put, like for this one, was there a color change? Put down color change, and what color? Or were there gas form, bubbles form? Or was there a temperature change? It got cold or hot? Or the last one, was there precipitate? I think I covered all of them. Let's go back up here. Color change, gas form, precipitate, temperature change. And whatever you see in the video, or if you do it yourself, you're right here. If there's no change at all, well, you write that. And you try all these. Oh, this is one of my favorite. This is cool too. They're all nice. That's why I picked them up. So after you do that table, from the table, you will answer the following questions. And by the way, I gave you a fun one, the last one. What was your favorite chemical change? And that's the lab. It looks like it'll be a fun lab for you. Assuming you all have internet access to YouTube, which if you're in an internet class, you should have internet access from somewhere. And with that, it's noon. It's time for me to say bye. I'm done for today. Have fun with today's lab. It's due next Thursday. Remember, the one I talked about last Thursday is due today by, I think, 5 p.m. And with that, I'll say goodbye. Gang gesund. Hold on, let me finish. Goodbye, gang gesund. Be healthy, and I'll see you on Tuesday. Next Thursday, I'll put out an email what problems that we'll be working on. With that, goodbye.